Thank you and welcome. I want to thank the Saban Theatre and Rabbis Barron and Pador for all their efforts in making tonight's event possible. I'd also like to thank our co-sponsors, the Skeptic Society, the Discovery Institute, and the Centre for Inquiry, making tonight possible. Tonight's event is brought to you by the American Freedom Alliance, of which I'm the president. It's an organization devoted to upholding Western ideals and values and identifying threats to Western civilization. And this event caps a 5-week series of events we have run examining the conflict between evolutionary theory and intelligent design. And we have felt that this series of lectures, film screenings, and other discussions to be of tremendous importance to the future of the West, involving as it does matters of sociology, psychology, economics, religion, and of course politics. We offer a number of wonderful monthly programs, including the Literary Cafe, the Cinema Gateway, and our lecture series and conference series. Next year's program is contained in a flyer that we'll have available for you after the program. And to finish off 2009, we have a premiere of a great new film called You and Me, a documentary on the United Nations, which will be screened in Santa Monica on Thursday, December the 10th. And I encourage you to take a flyer about that particular event. 150 years ago, Charles Darwin's book on the origin of species was published in the United Kingdom. The book had been simmering in Charles Darwin's mind for nearly 30 years as he methodically gathered his evidence to prove his theory that natural selection through random variation had been responsible for the development of life on Earth. He published his book knowing full well the firestorm of protest it would ignite in Victorian England. His theory that organic life, developed with no apparent guiding hand of design, was revolutionary, challenging the very foundations of Victorian England and of scientific inquiry. But Darwin did not have the tools we have today to uncover the mysteries and the secrets of the past, and did not live long enough to witness the remarkable discoveries of modern science, from the structure of the atom to the discovery of DNA. But he did recognize that the fossil record, if the fossil record did not produce adequate evidence, then his theory would be in jeopardy. And we're today still left with questions. Is random mutation and natural selection sufficient to produce new forms of life that have arisen throughout history? After 150 years of Darwinism, the unearthing of millions of fossils, the commissioning of countless scientific papers, are we any closer to ascertaining the truth of who we are and where we are from? In the end, how adequate has Darwin's theory and its modern version, Neo-Darwinism, been in explaining the origins of life? That, ladies and gentlemen, is the question we're going to debate here tonight. And we could not have 4 more illustrious individuals to do so. For the affirmative, we are fortunate to have with us Michael Shermer. Dr. Michael Shermer is the founding publisher of Skeptic magazine, the editor of Skeptic.com, a monthly columnist for many magazines. Dr. Shermer's latest book is The Mind of the Market on Evolutionary Economics, and his last book was the bestseller Why Darwin Matters, Evolution and the Case Against Intelligent Design. Accompanying him is Donald Prothero, who is a professor of geology at Occidental College in Los Angeles, a lecturer in geobiology at the California Institute of Technology in Pasadena. He's currently the author, co-author, or co-editor of 21 books and almost 200 scientific papers, including 5 leading geology textbooks and 3 trade books. For the negative, we have Dr. Stephen Meyer, who is the director of the Center for Science and Culture at the Discovery Institute in Seattle. Dr. Meyer received his PhD from Cambridge University and is author of peer-reviewed publications in technical, scientific, philosophical, and other books and journals. His latest book is Signature in Cell, DNA and the Evidence for Intelligent Design, which has just been chosen by the Times Literary Supplement as one of the top books of 2009. He is accompanied by Dr. Richard Sternberg, who is a research scientist at the Biologic Institute and a research collaborator was a research collaborator at the Smithsonian's National Museum of Natural History. He holds a PhD in biology, in molecular evolution from Florida International University, and another PhD in systems science, theoretical biology from Binghamton University. From 2001 to 2007, he served as a staff scientist at the National Center for Biotechnology Information, and from 2001 to 2007, he was a research associate at Smithsonian's National Museum of Natural History. Please welcome our guests. Once again, the debate topic for tonight: has evolutionary theory adequately explained the origins of life? And to avoid the debate's descent into a contest over definitions, all four panelists debaters have agreed to the following definitions. Evolutionary theory means new forms of life and their distinctive features and structures arising from simpler pre-existing forms of life as natural selection sifts through random mutations and identifies the most efficient forms and systems for life's continuation. Origins of life means origin of the first life from simpler non-living chemicals and the development of new living forms from simpler pre-existing forms. Adequately means has biological evolutionary science provided the public with sufficient evidence to establish that simple forms of life developed into complex forms. Now, I just want to go over the schedule for the debate and some of the rules. For the first 25 minutes, we'll have a presentation of the affirmative argument, followed in the next 25 minutes by a presentation of the negative argument. Following that, there'll be a rebuttal phase, and each side will be given two opportunities to rebut the statements made by the other side and clear up any confusion surrounding their own arguments. Then there will be questions from the moderator, myself, and the audience. We will pass around cards to you with pencils shortly before the rebuttal phase ends for you to fill out, submit your questions. I will then choose the questions to submit to the debaters. Finally, the concluding statements. Each side will have 5 minutes to conclude their arguments and present them in a concise way. Some of the rules. All speakers will adhere strictly to their time limits. Audience members will not be permitted to ask questions directly of the speakers. Questions must be written down on cards and presented to the ushers who will be passing among you and then presented to me. At the conclusion of the debate, the moderator will announce book sales and book signings in the lobby. Debate participants will immediately proceed from here to the lobby to sign sign their books. And that is the introduction for this debate, and I would now like to call on Dr. Shermer to present the first argument for evolutionary theory.
Welcome. Thanks for coming out. Such a beautiful warm night. And to my debate opponents who are from out of town, I'm sorry about this blistering cold winter weather that we're having here. So I'm going to just give some general background about what I think are some of the meta issues involved in the debate, and then I'll turn it over to Don Prothero to take up the technical details. In 2004, in his book, The Design Revolution, the intelligent design leader, William Dembski, said, quote, "Scientific creationism has prior religious commitments, whereas intelligent design does not." Baloney. On February 6, 2000, Dembski told the National Religious Broadcasters Convention in Anaheim, quote, "Intelligent design opens the whole possibility of us being created in the image of a benevolent God. The job of apologetics is to clear the ground, to clear obstacles that prevent people from coming to the knowledge of Christ. And if there's anything that I think has blocked the growth of Christ as the free reign of the Spirit and people accepting the Scripture and Jesus Christ, is the Darwinian naturalistic view. In a feature article in the Christian magazine Touchstone, Dembski was even more succinct. Quote, "Intelligent design is just the logos theology of John's gospel, restated in the idiom of information theory." Finally, listen to the words of Philip Johnson, the University of California, Berkeley law professor, sort of the grandfather of the modern intelligent design movement, at that same National Religious Broadcasters Convention in Anaheim. Quote, "Christians in the 20th century have been playing defense. They've been fighting a defensive war to defend what they have, to defend as much of it as they can. It never turns the tide. What we're trying to do is something entirely different. We're trying to go into enemy territory, their very center, and blow up the ammunition dump." What is their ammunition dump in this metaphor? It is their version of creation, close quote. Finally, Johnson was even blunter in 1996. He said, quote, "This isn't really, and never has been, a debate about science. It's about religion and philosophy." So I just wanted to put that out on the table so that we're clear what we're really talking about tonight, just in case it isn't obvious. Now, of course, this is something called the genetic fallacy, like somehow I've just dismissed their science, and no, I haven't. But I just want to be clear about what actually I think is going on here tonight. After all, Francis Collins, who's was the head of the Human Genome Project, now the head of the National Institutes of Health, he believes everything these gentlemen believe about the Christian religion, and he does perfectly good science. So what's the difference here? Francis Collins fully accepts all of evolutionary theory. He even conceded to me last week that he now largely accepts my own evolutionary theory on the origins of morality, that you don't even need an outside source for that God could have built into the system through evolution a development of a moral sense of right and wrong. So let me now turn to what I think are the actual flaws, regardless of what the religious agenda may be. I think there's only two explanations to answer the question of what's the origins of life or the diversity of life. One, science. Two, everything else. Within science, we're talking about natural explanations, bottom-up natural explanations for X, whatever X is, the origins of life, the evolution of life, the eye, the wing, whatever, solar system, the planets. And two, under everything else is, well, what? Well, you can hear that from their side tonight. But I would include in that supernatural explanations. That is, these are what we call God of the gaps arguments. In science, we have a certain assumption. It's called methodological naturalism. That is, we assume that there are natural explanations for natural phenomenon. Every argument from the intelligent design theory side sounds something like this. X looks designed. I can't think of how X was designed naturally. Therefore, X was designed supernaturally. It doesn't matter what the X is. You can fill in the blank. They'll have some new examples tonight. It used to be the wing. Then it was the eye. Then it was the bacteria flagellum. And now it's DNA. It's getting smaller and more molecular in size. But the X is still the X in principle. Now, I'm willing to concede the word design. Things are designed. Wings are designed to fly. Eyes are designed to see. The question is, who or what is the designer? Darwin gave us an explanation of how design comes about naturally from the bottom up. Now, it's possible that that's not the full explanation. Perhaps there's some built-in, self-organized, emergent properties that are still to be discovered. Something along the lines of what Stu Kaufman and some complexity theorists and chaos theorists study when they study complex systems. But they're not invoking any supernatural forces there. They're still talking about bottom-up natural forces. So, for example, on page 443 of Stephen's new book, He says theories, especially origins theories, needn't be either scientific or religious. They might be both. Or more precisely, some scientific theories, although not themselves religious, might have philosophical or religious implications. True. But that isn't the point. That's not the problem. Stephen, the problem is not that you're religious or you're Christian or whatever. That's irrelevant. As I said, Francis Collins is, and he still does good science. The problem is that by invoking something that is by definition not testable, there's no experiment we can run, you're now off the page of science. So by invoking some kind of extra-natural, supernatural, supranatural, paranatural, something beyond the natural, there's nothing we can do with that. It's kind of a conversation stopper. It ends the discussion. You quote, Stephen, the great Isaac Newton in his invocation of the deity to explain what keeps the planets going. Why does nobody invoke that argument in astronomy and cosmology? Nobody does. They cite the great Isaac Newton where he was doing science, but where Isaac Newton abandoned his science and said, well, you know what, I can't think of how gravity could explain the overall origins of the solar system. I think that is where the divinity came in. Nobody invokes Newton for that. And it's not because Newton was religious, and you're not supposed to be religious. Lots of scientists are religious. It is that he wasn't doing science. And once you're off the page of science, then you've taken yourself out of the discussion. Thank you.
All right, I'm the second part of this tag team here. I'm the scientist in charge of the other half of it. And I'm going to talk strictly about scientific approaches in most of this talk, not about the metaphysical as much. My book is out on the table there. Most of this is a very short version of what you can find at length in the book if you want to read more. And as Michael just said, we're talking about testable hypotheses, hypotheses that must be addressed in a way where we're willing to throw out our established, cherished notions if the evidence is against it. And that's the way we test hypotheses in science all the time. And as Michael just said, and I'll repeat because it's important, we cannot resort to supernatural explanations. It's not because we're anti-religious. As Michael pointed out, about 50% of my colleagues are religious as well. It's because religious ideas are simply not testable. There's no way to say God did it and then find a test that works, or the intelligent designer did it, or whatever. There's no way to test it. A very nice little cartoon by Sidney Harris says it very clearly. Our little scientist there is working along, and then he has an equation where then a miracle occurs. As you see the other scientist saying, I think you should be more explicit here in step 2. I'll turn this so I can see it. And the question we must address here is not just does Darwinian science address the problem we're talking about tonight. The intelligent design people can't say, well, they didn't do it well enough, therefore we win. They have to actually explain how it works. That's the only way a scientist does things. They don't just say, oh, I don't buy your explanation, therefore I win. Okay? And if they're going to talk about intelligent design, they must be willing to test the idea that if you look at the world, does it appear to be intelligent design? And there are lots and lots of examples of bad design and crummy design in nature. I'll just show you a couple of them. In your chest right now is the left recurrent laryngeal nerve, which I don't think I can point to too well, but here it is right here coming off the vagus nerve, looping underneath your aorta, and then way up back to your larynx. It's 3 feet longer than it needs to be. Okay? Could take the direct route right off the vagus nerve and right to your larynx. You say, well, why would an intelligent designer make that completely weird course of the nerve, which in fact it can subject you to all sorts of problems if you kicked in the solar plexus? Okay? The reason? Because that nerve is tied to a gill arch that is tied to the aorta when you enter an embryo, and then the aorta moves backwards, so does the nerve. And in fact, it's a real problem for giraffes. That nerve is 15 feet long because they have long necks, and it makes no sense whatsoever. As some of you know, in your retina right now, your light-sensing rods and cones are on the bottom layer, facing away from the light source, and they're subjected to all sorts of distortion of light from the tissues and blood vessels that sit above them. Okay, and also, as some of you know, up there in the back part of the retina, you have the ocular nerve coming out right there, which creates a blind spot. Not a very good way to design a retina. If you want to look at a well-designed eye, look at an octopus. Much better than ours, okay? Their rods and cones face forward, and they have no blind spot. Many organisms in nature have these limited function or non-function or reduced function vestigial organs that are evidence of their ancestry. For example, whales have vestigial hips and thigh bones in their bodies. Here it is on the skeleton of a whale mounted in a museum. They'd have no function whatsoever now. They're only evidence of four-legged whales, which of course we have fossils of now as well. The same is true of snakes, horses with 3 toes, and so on. And as Michael said, the whole idea argument is basically a God of the gaps argument. Too complex to explain by natural processes, therefore must be a designer. And as Michael said it so nicely, and I agree, I can't figure out how to explain it, is what they are basically saying, therefore no one can, which is pretty arrogant, because eventually somebody will. Okay? This is not a legitimate scientific way to tackle a problem. There are many, many unsolved mysteries in science. That's a good thing about science. It's always open-ended, okay? We don't just give up and say, oh, can't explain it by science so far, therefore we should fall back on supernaturalism. That's a cop-out, okay? That's a non-explanation. Now, the problem of the origin of life is admittedly a very difficult problem, and scientists have been working hard at it for about 50 years now in intense ways. The major problem, of course, being that there's the original evidence of it, it's all chemical, which is not something that fossilizes very well. But despite what you might hear from creationists who ridicule and trivialize it, enormous progress has been made on the chemical side of this. And as I'll show you, enormous progress has also been made on the fossil record side. We don't yet have life in a test tube, but there are several labs that are very close to it as I speak. But just because we don't have all the pieces of the puzzle yet doesn't mean we give up and say, too complicated, therefore I don't believe it's going to be proven. The experiments run all the way back to the famous Miller-Urey experiment in 1953, which showed amino acids are very easy to build. In 1 week, he made 4 of the amino acids of life. His original gunk was found in his freezer after he died, and now there are 22 amino acids found in it. Later experiments have produced nearly all the 20 amino acids found in life, and now they've looked at meteorites, and it turns out amino acids are everywhere in the solar system. They're incredibly easy to make. The next step in the argument, of course, is to link amino acids together to form proteins. This has been done by many different research labs over the last 50 years, going way back to the 1950s. You can splash amino acids on dry rocks and polymerize them to proteins. You can react them with cyanide, with clays, with heat. Proteins form in lots of ways. The cell wall that surrounds every simple cell is a series of bipolar lipids, which are naturally polarized. They have this water-hating end right here in the little tails you see, and a water-loving alcohol on the other side. They naturally line up just like when you mix Italian dressing, right? Oil and water droplets and form little droplets which have the same properties in many ways as cells. Nucleic acids are by far the most complicated thing to develop, but they've been synthesized in lots of ways, by heating in cyanide, by UV radiation. A paper just published a few months ago by Sutherland et al. Actually created ribonucleotides and very simple early Earth chemicals, and they were fully complicated and fully operational. Many, many experiments done on how you do these things, wetting lipids to produce droplets, to then trap DNA and concentrate it 100 times. Famous experiments by Potton and Sidney Fox that made proteinoids which bud, change size, absorb and release compounds like bacterial feeding, excrete waste products, even metabolize starch. The only thing those things don't do is reproduce, and then with DNA. Here's some images from Sidney Fox and from Potton. And the beat just goes on and on. If you just follow the literature and read any of the stuff in the science press, stuff has been accumulating on almost a weekly basis for at least the last 30 years. The coding sequence of amino acids is easily built with small RNA templates in normal prebiotic conditions. The first ribosomes in the RNA world were much longer and more stable. Cyclic nucleotides can easily merge in water to form RNA over 100 nucleotides long. RNA molecules link up in long chains easily under normal Earth conditions. Several people have shown that the Urey-Miller experiment was right in the way that they modeled atmosphere, and even if they weren't, it still works, even in different conditions. And you'll hear these people say, oh, there are no new genes being produced. This has been done repeatedly in labs all over the world. Now, I'm a paleontologist by training. I'm one of those kids who got hooked on dinosaurs at age 4 and never grew up. Okay? And all my life has been focused on fossils, although I had a lot of background in biochemistry as well. And there, of course, the evidence is ironclad. Huge amounts of evidence, none of which these guys will ever treat very fairly. We have fossil record going all the way back to 3.5 billion years of the simplest bacteria. And then, as you would expect, evolution predicts from simple to complex, and sure enough, the fossil record shows that in spades. 1.7 billion years ago, we have clear eukaryotic cells, which have a nucleus. 600 million years ago, we have the evidence of the earliest phyla, the sponges, the corals, the arthropods, and so on, way before the Cambrian. At 580 million years ago, we have soft-bodied multicellular organisms with no skeletons yet. In the earliest Cambrian, 550 million years ago, we get these so-called little shellies, which have very small pieces of skeletons, and not until 520 do we get things as big as a trilobite. I'll show you a few images of these just to do this quickly here. Here's some images Bill Schopp, UCLA, loaned me. These are various bacteria and cyanobacteria he discovered in Australia. And over here on the right is the modern cyanobacterium Lingbia, which is a dead ringer for these fossils. You'll hear our opponents probably say something along these lines. This is from Meyer's 2003 paper. The body plans and structures present Cambrian period animals have no clear morphologic antecedents to earlier strata, and the Cambrian explosion lasted only 5 million years. And this is a figure from their paper. It's false. Okay, and I'll show you why in a second here. This statement is also false. It's not a Cambrian explosion. That's an unfortunate old-fashioned term that's completely out of date. I like to use something a little more modern, like Cambrian slow fuse, which is really what it is. I'll show you this evidence very quickly here. We had 600 million years ago the first evidence of multicellular animals in the forms of embryos of sponges, cnidarians, worms, and arthropods. Almost all the major phylum marine invertebrates that have a fossil record 50 million years before the Cambrian. Okay? And at 580 million years ago, shortly thereafter, we get these big multicellular soft-bodied things, the so-called Ediacarofauna, which are worldwide and known from many different kinds of interesting localities. They're soft-bodied, but they're quite large, but they don't have skeletons yet. In the very beginning of the Cambrian, before trilobites, we get these little shellies. These are mostly a millimeter or two across, and you can see the ones up here are very clearly mollusks. Many of these are spicules of sponges. They're all members of phyla, which we have recognized from later in the Cambrian, and they're all well before the complex so-called Cambrian explosion. If you actually go to the outcrops, which I've done myself, and I doubt that either of my opponents has ever seen or collected like I have, this is the outcrop in Daldana River in Russia. You can see this entire sequence right in the cliffs as you climb up from the bottom to the top. It's a very long, protracted event, taking over 80 million years. So Cambrian explosion is not 5 million years long. It's from here all the way down to here, which is well dated to 80 million years. And that's hardly explosion by my standards. You'll hear my opponents talk about information. Okay, they constantly say life is too complex. Something had to insert information into it, put it in make of some kind of designer. And once again, that's a God of the gaps argument. Okay. Moreover, there are many biological and non-biological systems that assemble naturally from simple to complex. Here's a classic example, a very simple reaction, which some of my coaches suggest I actually perform on stage for you. It's known as the Belousov-Zhabotinsky reaction. All you need is an organic solution with some bromates, some cerium sulfates, citric and sulfuric acids, add a catalyst, and boom. You get a reaction that's self-propagating and has a cyclic nature, just like the Krebs cycle, and keeps going indefinitely. And several of these ID creations, like Michael B. has said, the Krebs cycle cannot be explained by normal chemistry. This is exactly like it. Or you'll hear my colleagues say, or my opponents here say, information. So let's pose a question. What do we mean by information? What kind of systems are we talking about? They're going to talk about biological systems. Well, let's look at this question. What kind of natural system builds up from simple to complex, has mutations, replicates those mutations, gets much more complex, and increases its information? And you probably think you know the answer. No, you don't. The answer is mud. It turns out, if you go look at common mud, it's made of simple silicates known as clay minerals, which combine very easily by electrostatic contraction from very simple little tetrahedra to chains, to single double chains, to these big sheets. And then once you get them into sheet structures, you get very complicated structures that go indefinitely for very long distances up and down the screen and right to left and in and out of the screen. These are all sheet silicates. You can see on the lower left there what they look like. They look like little books on side view. And they get bigger and bigger and propagate themselves. And more impressively, this has been shown by a number of clay mineralogists, including friends of mine, when they have lattice defects or weird substitutions or so on, those are reproducible. The clay minerals that grow from this template will reproduce the same mutation, the same defect, and grow with that mutation and carry on. So you can have these things growing on, and they will keep on growing as long as they have the right conditions, until you get very large self-reproducing systems with mutations and replication. The only thing they're not is living. So we hear them say over and over again, complex biomolecules require design. Well, actually, clay minerals are more complex. They mutate and they replicate. So if they're going to apply that standard, then we're going to have the intelligent designer create every drop of mud individually. So I will wrap up here. I don't know how my time is, but I'll wrap up my time here. As Michael said, we have some issues here, but one of the big issues is, are these guys playing by the rules of science? Have they done any serious science? And I think we'll show tonight they did not. Virtually all their scientific research is borrowed or copied from other people. I don't seem to see any example of real lab work by these people. Their basic publications are criticizing works of real scientists. I never see any of these guys at scientific meetings, and I go to all of them each year, okay? They're very limited publications of peer-reviewed literature, and I'll talk about that later if it comes up in questions. And more revealing, as Michael pointed out at the beginning, what's really behind this is nothing about science at all. All these people have, in one way or other, revealed that their whole dogma is driven by religious motives, which is not a bad thing in and of itself, but it has nothing to do with science. And before they took it off the web, but you can find it very easily, it's all sorts of places to find it on the web now, they have what they call the wedge strategy. It was a very clear document issued by Meyer's own institution there, which basically revealed that the whole intelligent design movement was a response to the Supreme Court ruling out young Earth creationism and direct mentions of God. Within months after that Supreme Court decision, ID rose up. It was a PR strategy, and that's really still all it is. It's basically to insert themselves into public education because creationism is unconstitutional under the First Amendment, and also to basically get around the scientific review process by doing it through PR and through public information and through biasing the public rather than try to get their work actually vetted by the scientific community. And if you doubt me, I will do like Michael did and quote them in their own words. This is from Paul Nelson, one of his colleagues over there in Seattle. Easily the biggest challenge facing ID communities is develop a full-fledged theory of biological design. We don't have such a theory right now, and that's a real problem. Without a theory, it's very hard to know where to direct your research focus. Right now, we've got a bag of powerful intuitions and a handful of notions such as irreducible complexity and specified complexity, but as yet, no general theory of biological design. Now, you tell me, is that science? It would not pass muster in any scientific community I know of. And then this is from Philip Johnson, as Michael mentioned, the grandfather of the movement. I also don't think there really is a theory of intelligent design at the present time to propose as a comparable alternative to Darwinian theory, which is fully worked out scheme. There is no intelligent design theory that's comparable. No product is ready for competition in the educational world. And of course, in 2005, Judge Jones, a George W. Bush appointee in the Dover trial, agreed with these sentiments, even though they were not his, the sentiments of his court, and said that intelligent design is not science, and that's still where it stands legally. Thank you.
I'd like to invite the negative side now to present its case.
Do you get the feeling that Professor Prothero regards himself as an expert about facts that we don't know about? That this is essentially a debate between smart science guys who know a whole bunch of stuff and religiously motivated people who don't know anything. He threw out a whole lot of things. Tonight we're here to debate the sufficiency of evolutionary theory. We were not invited to debate the theory of intelligent design. We would happily challenge you to a direct debate about that topic some other time. But we came prepared to discuss the sufficiency of evolutionary theory, which is, in modern form, neo-Darwinism, and its idea that mutations, that natural selection acting on mutations can build fundamentally new forms of life. I want to just rebut one thing, and I'm going to hand it over to my colleague, Richard Sternberg, very quickly. We've both come prepared with two scientific presentations about the sufficiency of evolutionary theory, explaining why many scientists, not just members of the ID community, are now questioning the adequacy of the mutation and selection mechanism. But just so you know, this isn't a debate about the facts. I've got Dr. Prothero's book open about the Cambrian explosion. He says it's not an explosion, it's a slow fuse. But he also says it's a series, it occurs in a series of steps, essentially a series of explosions. We don't dispute any of the things that he has on his little time chart. I'm fully aware of those. But what's important in the Cambrian explosion is that you have the appearance of what is called evolutionary novelty, structures, anatomical structures that did not exist before. For example, the lens-focusing compound eye in the trilobite. In the Mao Shashan Formation in southern China, where we have sent researchers, there is the trilobite first appears with that complex system. It appears in a sequence of sedimentary rock, which has been dated by Samuel Bowring of MIT as having taken about 3 to 6 million years. It's true you can stretch the Cambrian out to 80 million if you want to, but to do that, you've got to count hypothetical common ancestors that haven't yet been identified. You've got to account ediacaran fauna that do not have the distinctive morphological and anatomical features that first arise with the Cambrian phyla in the Mao-Shashan Formation. So this is not a debate about the facts, it's a debate about the interpretation of the facts and the logic you use to do so. From an evolutionary point of view, it's still very important that you account for the origin of all that new form and structure in such a sudden burst of innovation and creativity lasting no more than 3 to 6 million years. Now, the debate we came to discuss tonight was the sufficiency of evolutionary theory. And I'm going to zip forward to the beginning of the presentation that we plan to make and make a point that there's a difference between observations of evolution, of change, and we've had a whole bunch of, we got the whole history of life there in about 20 minutes, and the cause of the changes that have been observed. Evolutionary theory attempts to explain the origin of new forms of life as a result of mutation and selection, principally. The question is that mechanism sufficient to produce all the forms of life that we see today, especially the major changes that have occurred in the history of life? Now, one of those major changes is the origin of whales from presumably land-dwelling mammalian ancestors, some deer-like creature. This is, according to Michael Shermer, one of the best examples of the Darwinian process in action. And so my colleague Richard Sternberg is going to take on this poster child of evolution in action and show that the mechanism of natural selection and random mutation is not sufficient to produce the change that is on display in the fossil record. And he's going to do that using population genetics, which is the mathematical expression of modern evolutionary theory, modern neo-Darwinian evolutionary theory. In other words, he's going to use the theory itself to show the theory's inadequacies. Richard?
Good evening, ladies and gentlemen. Thank you, Steve. I trust you can hear me well. The sequence of forms that I have above me, very close to very similar to a figure that you have in your book, Doctor. From the first impression of it is a nice transitional series, a nice progression of forms. You start out with a wolf-like or pachycetid ancestor, and then you end up with fully aquatic whales. And moreover, it's something that appeared in a well-known time frame. So you have this transition starting out from a true walking whale and ending up with a fully aquatic creature in a period of, what? Roughly 9 million years. I'm taking one estimation, a monograph on Dorodon that said starting from Pachycetus, ending in Dorodon is a time frame of 9 million years. Well, the sequence that we see here, starting from a common ancestor and ending up with a derived form, is a pattern. It's a pattern to be explained. The morphing that we can imagine in our minds, in and of itself, is not a causal explanation. And you are right. What we have to do is provide testable hypotheses. And there is a testable hypothesis that has been proposed. It is that you have random mutation rates and recombination, and then you have selection coefficients, and what you get is incremental change over time, which for many people is the definition of evolution. Now, what's interesting is that in the past 2 years, several papers have been published, quite interesting papers that show that this nice progression of forms, and I don't question that progression of forms, by the way. I'm not a young Earth creationist, and I'm not an old Earth creationist, as insinuated, but that this progression of forms was rather more abrupt. Some of the sequence, for example, if you look in the middle, you've got a taxon like Gaviacetus and Protocetus and Georgiacetus. These are called protocetids, and they're depicted as having rudiments of tail flukes and reduced hind limbs, and essentially they look in between a walking whale, a terrestrial whale, if you will, and a fully aquatic whale. But what we now know is that from the skeletal evidence is that the transition took place from creatures that gave birth on land, that had well-developed pelvises, that had well-developed hind limbs, that had a sacrum, sacral vertebra, to creatures that had highly reduced hind limbs, no sacral vertebrae, absent pelvises, and that gave birth in a fully aquatic environment. And moreover, if you take seriously, and I do, that this transition occurred from Pakicetus to a true marine whale in 9 million years, then this transition from these protocetids to fully aquatic whales was rather abrupt in a few million years. Now, what's interesting is that if you get a good textbook on cetacean anatomy and embryology, and you look at the development of these structures, or just some of the soft tissue parts that are necessary that you could never discern from looking at the bones, you know that to even have a basic fully aquatic whale in and of itself is a feat of engineering. I'm not saying intelligent design, I'm just saying engineering. What do you need? You need a countercurrent heat exchange because the testes are inside the body. You need a ball vertebra. Why? Because unlike a dog's tail that wags from side to side, you have to have a tail that moves up and down. You have to have the tail flukes. They're not found in the protocetids. They're only found in the fully developed aquatic whales. You got to have the musculature for it. You have to have the reorganization of kidney tissues. Why? Because you're not drinking fresh water. You have to intake salt water. You have to nurse young underwater. You have to modify the mammary glands for that. The orientation of the fetus of, for example, the protocetids, the so-called intermediates, we know were like those of terrestrial mammals. However, in the case of whales, the orientation is reversed. You get reduction of the hind limbs, forelimbs transformed into flippers, hydrodynamic properties of the skin, special lung surfactants. When whales dive and they come back to the surface, the lung has to re-expand and it has to do so very quickly. Novel muscle systems for the blowhole, modification of the eyes, modification of the teeth, and it's on and on. So what do you have? You have, in a short window of time, hundreds, if not thousands, of character state changes. Dramatic reorganization. Now, my question is very specific. Can this geological pattern that I accept and that I'm not going to attribute to outside intervention of any form, can this geological pattern, this progression of forms, be explained by the processes of population genetics? And there, in other words, does neo-Darwinism, and just neo-Darwinism, provide an adequate causal explanation for the origin of these structures? Well, what is neo-Darwinian evolutionary theory? It's essentially that mutations generate variation. There are different kinds of mutations, different frequencies. Natural selection preserves the successful variants. And therefore, if new traits are necessary to produce a different biological form, depending upon the number of traits, then it's assumed that you have many adaptive mutations that had to arise and had to be preserved. All right? And how do you test this? Well, you can apply the equations of population genetics, and you can model them. You can get a textbook, and it's done all the time. I brought some of the literature with me. And you can determine the plausibility, whether or not there were enough mutational resources available for a given scenario to work. In other words, you can ask, was there enough mutational grist for the mill of natural selection? Now, it's a numbers game. What do you need? You need three necessary factors. Many generations, that is to get the number of traits appearing, and you have to have many generations and or rapid mutation rates and or large population sizes. One more requirement, that it's not enough just to get a mutation. It's not enough for a gene variant to appear in a population. It's got to be fixed. It's got to go from that initial infinitesimal copy, the lone individual out there, to becoming the norm that's established. If you do not have these, then you have two possibilities. One is that variation becomes exhausted in a lineage. And you see this, for example, with endangered species or populations that suffer from what's called inbreeding depression. Or you can have that, but you also have what's called genetic drift, which means that you do not have the population sizes necessary for natural selection to be effective. And the population literally drifts. It's a random or nearly random process. So, I assert, and I'm only talking about neo-Darwinism, and I'm not talking about anything else. I assert that there are three problems, and they're readily identifiable. One is that there were too few generations involved in the transition. I'll explain why. One is that the adaptive mutation rates, known adaptive mutation rates, are far too low. And the third is that mammalian population sizes are far too small. Now let's look first at adaptive mutations. I drew how I calculated this on a board, so should there be any questions, I'll be happy to walk you through it. What I calculated here, given a known rate of an adaptive mutation, this is a mutation that appears and doesn't just affect a trait slightly in a positive way, but it affects a number of traits and in a positive way. And we know these from organisms that we can study well. Bacteria, viruses, and fungi, like yeast. And what I did is I took 3 breeding population sizes. Think in your mind, these are walking whales I'm talking about. And all that matters are the individuals that reproduce. The rest you don't factor in. And I plugged in how long it would take for one adaptive mutation to appear in a population. What population size would you need? And what we can do, very simply, is we can rule out 2 of them. And here's why. If you assume that, say, these walking whale populations were the same size that we know of some very large animals, large mammals, for example, say 10,000 breeding individuals per generation, 5 years per generation, then we know, well, you can readily calculate, it would take around 136 million years for that to appear. But guess what? You have 9. And in case for many of the trait changes, you have far less than that. If you assume a breeding population of 1 million individuals, you run into a problem, and here's why. With mammals, breeding population sizes are in the tens of thousands to the hundreds of thousands. House mouse. House mice exist in millions, if not billions, of individuals globally. And they're breeding and they're doing their business underground. But here's the thing. The breeding population size of the house mouse is around 600,000 individuals. It's between 410,000 and roughly 800,000. In our case, hominids, until very recently, the breeding population size was around 20,000 individuals per generation. So numbers matter. So let's put that aside. But what if you needed multiple coordinated changes to affect the transitions that I've illustrated? Here going from Protocetid, Georgiacetus, to a Dorodon, actually Basilosaurus. Well, let me give you an example of one. This is a cetacean countercurrent heat exchange system. Cetacea have their testes on the inside of the body, right next to the muscles that generate heat during swimming. Now, what happens in mammals is that if the testes are in the inside of the body and they're not cooled, you have sterility. So you have to cool down the glands. And this is done, similar to a modern refrigeration system, by shunning cool blood from the tail flukes to a plexus, or nexus, if you will, of arteries and veins that dissipates the heat from the gland. So even though a cetacean is moving in the water column, the testes are remaining below core body temperature. Now, let's assume, and I think this is an absurd assumption, that only 2 mutations were necessary for this complex adaptation that I've just shown. We can assume that it was far simpler than that. It doesn't matter. Yeah, coordinated mutations. Durrett and Schmidt, 2008, have an interesting paper in genetics, and they were attempting to refute Michael Behe's book, The Edge of Evolution. And they calculated the probability of getting 2 coordinated mutations, very simple mutations, not in a protein-coding gene, but just in some DNA sequence that, say, would bind a factor. Well, the probability and in various population sizes. And their conclusion was that, well, you could get these 2 coordinated mutations in the human lineage. You've only got 20,000 individuals on average per generation, once every 216 million years. Now, if you factor in that the human-chimp divergence was 5.5 million years, it seems that it's rather unlikely. For walking whales, if you adjust the equation to say, well, you're dealing with more individuals, that adds up to around 43.3 million years. That's just the paper and the calculations that they used to come up with that conclusion. So here's the nub of the issue, and the only issue I'm here to discuss tonight. If the evolutionary process, and by that I've defined it as neo-Darwinian theory, would typically produce only two coordinated mutations in 216 million years in a hominid lineage. And if in these aquatic mammal precursors, these whales, the evolutionary process would have only produced two such mutations in 43 million years, how could this process alone have produced fully aquatic cetaceans with their multiple anatomical novelties, requiring many hundreds, even thousands, of adaptive changes in less than 2 million years, even less than 9 million years, perhaps even 50 million years? Dr. Meyer, I will think, but if you have any questions about that? I'm saying it doesn't add up, yes. Thank you.
I've got everything in 5 minutes. Okay. I'm going to make an additional point. The idea of population genetics was hatched in the 1920s and 30s before we knew about the information revolution in biology. And as a result of that, it made a number of assumptions that are still with us today and yet are not well founded. The main assumption it made was that it's easy to produce new traits by making with mutations. Genes were thought to be unitary entities prior to 1953. You change a gene, you automatically get a new trait. People didn't know how frequently they occurred, but it was assumed that it was easy to generate new traits by mutating genes. Since 1953, with the recognition that genes are actually sections of digital code along the DNA molecule, that assumption of population genetics has had to be revisited. And what it means is that as difficult as the problem is from the standpoint of neo-Darwinism and its mathematical expression in population genetics, the problem of generating new biological form, anatomical novelties, like all these cool structures that Rick was talking about in whales, is even more difficult. And in particular, what we've recognized is that building new complex animals does indeed require lots of new information. Not complexity, as Dr. Prothero referred to it, but information, specified arrangements of sequences. If you think about mutating something, and you realize that you need information to build a new organism, just like you need new information to give your computer a new function. And you begin to think about it in light of the information revolution, it raises some other questions about the power of mutation. Ask yourself a question. If you've got a section of digital code, a section of alphabetic text, and you begin to randomly change it, blindly, are you more likely to degrade the meaning and function that's there, or are you more likely to enhance it? Clearly, you're overwhelmingly more likely to degrade it. And one of the reasons for that is it turns out that the ratio of the number of sequences of alphabetic characters that perform functions or are meaningful to the sequences that don't is very small. In a 10-letter sequence in the English language, there is one functional sequence for every 10 to the 14th, or 100 trillion non-functional sequences. So inevitably, you start to degrade things, you're going to move the sequence away from function into non-function. Now, this was intuitively, biologists thought the same thing in the 1960s about mathematicians, in particular mathematicians and physicists at MIT, who began to think about the plausibility, the mathematical plausibility of mutational theory. But they didn't know how, if the same thing was true of genes and proteins, that the ratio of the functional sequences were very small. The ratio of function to non-function was very small. And this question was taken up building on the work of an MIT scientist named Robert Sauer by Douglas Axe, who is the director of the laboratory at the Biologic Institute, which is where much of the laboratory research that Dr. Prothero says is not done is done. Axe began his research at Cambridge University, and he asked a critical question. The question was this: how rare or common are the functional sequences of genes or proteins in relation to all the possible ways there are of arranging the base characters in the genetic message or the amino acids in the proteins? If it turned out that the sequences were very common, that functional sequences were common, it was possible to imagine that by mutation you could kind of skip from one island of function to the next very readily. But if it turned out that the ratio of functional to non-functional sequences was astronomically small, then what you would have is a situation where mutation would be searching indefinitely, trying to find the functional sequences and not having enough time to do it, like looking for a tiny, tiny pin in a gigantic haystack. Well, through this period, 14-year research published in the Journal of Molecular Biology determined that the ratio of functional proteins to the corresponding space of all the possible ways there are of arranging amino acids of that given length is astronomically small. The ratio is 1 in 10 to the 77th power. So to get a handle on that, imagine this. Imagine that you're trying to find the combination on a combination log. But instead of having a combination lock that's just got 4 dials, or 10 as my artist has rendered, imagine you have one that has 77 dials with 10 settings on each one, and you have only one functional combination. Is it going to take you a little bit of time or a lot of time to search that space of all those possibilities to generate the new combination or information you need to unlock the lock? Obviously, it's going to take you an immense amount of time. And that is the measure the measure of the probability of generating one protein fold, a domain of a protein, not even the whole protein, okay, in axis research. Now, to build a new Cambrian animal, to build a lens-focusing eye, a compound lens-focusing eye in a trilobite, you're going to need many genes. To build the whole animal, you're going to need many genes. Arthropods have about 50 cell types, each of which have many dedicated proteins, many of which would not have been present in the immediate ancestor to the arthropods in the arthropod prior to that critical explosion that I talked about in my opening remarks. Now, one more problem as far as the generation of information. It turns out that you don't only need information to build genes and proteins. It turns out to build body plans, you need higher levels of information, higher order assembly instructions. DNA codes for the building of proteins, but proteins must be arranged into distinctive circuitry to form distinctive cell types. Cell types have to be arranged into tissues. Tissues have to be arranged into organs. Organs and tissues must be specifically arranged to generate whole new body plans, distinctive arrangements of those body parts. We now know that DNA alone is not responsible for those higher orders of organization. DNA codes for proteins. But by itself, it does not ensure that proteins, cell types, tissues, organs will all be arranged into body plans. And what that means is that the body plan morphogenesis, as it's called, depends upon information that is not encoded in DNA, which means you can mutate DNA indefinitely. 80 million years, 100 million years, till the cows come home, and it doesn't matter. Because in the best case, you're just going to find a new protein someplace out there in that vast combinatorial sequence space. You're not, by mutating DNA alone, going to generate the higher order structures that are necessary to building a body plan. So what we can conclude from that is that the neo-Darwinian mechanism is grossly inadequate to explain the origin of the information we need to build new genes and proteins, and it's also grossly inadequate to explain the origin of novel biological form, which is to say, it's not adequate. Thank you.
Thank you to all our debaters for staying within time. It was very impressive. I'm now going to call upon the affirmative to rebut some of the things that were said here, and you can rebut the rebuttal if you wish. This is an opportunity for us to really engage in debate. I'm going to encourage everybody now to fill out your questions and hand them to the ushers, and the ushers should bring them up to me.
Okay, let's see if the microphone's working here. Yes? Okay, good. All right, Stephen, you started off by accusing us of not addressing the question on the table, which is, has evolutionary theory adequately explained the origins of life? Your side didn't even mention the origins of life. So you just wasted your 25 minutes if you want to stick to the technical reading of the question on the table. And in fact, we did. Of course, I just blasted through in 7 minutes, and Don Prothero gave you a 15-week course in 15 minutes. He did 1 minute per week, and he gave you the origins of life and the origins of what you were concerned with, Stephen, novel biological forms, and showed you how you could even get information increase in mud by your definitions. So we, in fact, did address this quite clearly. My second point is that Dr. Sternberg made a point about the difference between the history of change within a lineage and then the causes of the changes. Here I would like to address both of you on this question. You said you didn't come here to debate or defend intelligent design theory. Really? Please tell me you didn't fly here 3,000 miles. You have a brand new book out that's 700 pages long on the evidence for intelligent design that they're selling in the lobby. And everybody here paid $20 to hear you explain how you think it came about, and you don't want to tell us? We'd really like to know. Inquiring minds would like to know. For example, we would like to know how many acts of creation you actually think there were. Just one? Maybe 10 every, say, billion years? Maybe 100 acts of creation? Are there a billion acts of creation where every single species is created but the subspecies are evolved? Are we to believe that you think every single rat living underground, Dr. Sternberg, is individually created by the designer? Or is there some natural process that gives rise to that variation? Now you, Dr. Sternberg, talked about the changes in the whale sequence there. This is what I call a fossil fallacy. That is, one or two or three or a few fossils do not a science make. That is to say, it's the whole package we put together, because evolutionary science is an inferential science. We infer from the data the activity that's going on. So, for example, here's what Dr. Sternberg did tonight. I'll show you here with a little visual demonstration. He says, here's a fossil whale, maybe a land mammal or almost a fossil whale, and here's one, and there's a big gap there. And Dr. Sternberg says, where is the fossils for that transitional? So we gave him some Ambulocetus natans. There's a beautiful one right there. Dr. Sternberg's answer, now there's 2 gaps in the fossil record. Now you guys got to come up with even more data. So the more data we provide, the more gaps it creates, and that's the fallacy with that argument. That is, he's arguing based on negative evidence, and the more positive evidence we provide, the more gaps there are for his God to fill. That's not science. And that's the problem with that. So, yes. That's fine. Okay.
Yeah.
Okay.
No,
Let's take the last point first. We may both want to jump in here on this. We're not talking about gaps. We're talking about the efficacy, the creative power of the mutation selection mechanism, which is to say the adequacy or lack of adequacy of evolutionary theory. What Dr. Sternberg was pointing out is that all the interesting characters that account for the distinction between a land-walking mammal and a truly aquatic whale occur in a 1 to 3 million year gap. Then he applied the equations of population genetics to what we know about population sizes, mutation rates, generation times, to assess whether the neo-Darwinian mechanism is adequate on its own terms to generate the amount of anatomical novelty that arises. That's nothing about, you're responding to us as if, right out of your debating manual, as if you're dealing with some young earth creationists who just fell off the turnip truck. This is a serious challenge to your view, and it is all, not about gaps, it's about the adequacy of the mechanism, and you have not addressed that. That is what we came to address because it was the topic agreed by both sides for tonight's debate. I am happy to come back and give a long lecture on my book and the evidence for intelligent design. And as long as we're on the topic, I will say, Michael, every time we have debated, you make the same charge against intelligent design. You claim that it's an argument from ignorance. I put up the same slide every time showing you that it's not, that it's an inference to the best explanation. Several times when we've debated, you concede my point, but then you make the next point the next time we debate. I, in fact, wrote about this in the book. Michael says that when we argue for intelligent design, and this is not the topic of the debate tonight, but as long as he's raised it, I will respond. He says that we say that certain features of living systems, for example, the specified digital information encoded in DNA, could not have arisen or has not been shown to have arisen by any known natural cause. I actually document that in my book. We're talking about the information necessary to produce the first life. Then he says, we say, and I can't think of how it could have done, therefore it was designed. He claims it's an argument from ignorance. That's not the structure of the argument. I argue that there are no known naturalistic processes that have been demonstrated to produce the digital code necessary to produce the first life, not processes based on chance, not processes based on law, not processes based on the combination of the two. But then I note that we know of a type of cause that is known to be sufficient to produce digital information, specified digital information. And that cause is intelligence. And that is something that we know from our uniform and repeated experience, which, following Darwin's own method of reasoning, is the basis of all scientific reasoning about the past. So therefore, using his method of reasoning, we can infer that intelligence is the best explanation based on what we know about the cause and effect structure of the world. Not a supernatural explanation, not a supernatural cause necessarily, but certainly an intelligent cause based on our knowledge of cause and effect.
But what could that possibly mean other than a supernatural cause?
Oh, there's two possibilities.
What does intelligence mean?
Intelligence we know from our own conscious and rational deliberation. You have an intelligence. This is what cracks me up, Michael. You guys think that invoking intelligence is some kind of mysterious thing that means you've jumped off the edge of the rational universe. What are you using but a conscious, deliberative intelligence to formulate the sentences you make in making that argument? Right. We know from direct introspection what it means to be intelligent, and therefore we also know what intelligence can do. And that forms the basis of our experience of cause and effect, which we can use to infer the presence, the antecedent action of an intelligence when we find the distinctive effects of intelligence, information, specified information being one such effect.
If I might weigh in here. All right, I will reiterate what Michael said at the beginning here. This debate is supposed to be about origins of life, and everything they've said on the other side is irrelevant, okay? They have not addressed that mountain of literature that I've talked about, thousands of experiments, hundreds of labs. It's all as if it doesn't exist, which is a pretty serious neglect. Let me get to the specific points that were raised in the original presentation they made. The Cambrian explosion. I quoted directly from Meyer's 2003 paper, and he said very clearly no antecedents and only 5 to 7 million years. And it's clear, in fact, there are antecedents. They are the Tomatian small shelly faunas, which are, in fact, members of phyla that precede the trilobites. And now we have the Dochenteau faunas 80 million years earlier.
Don, I don't know where you're getting that. We acknowledge in that Cambrian paper the presence of three Precambrian phyla. The point we make is that just because there's 3 phyla present in the Precambrian doesn't explain the other 16 or 32, depending on how you count, that arise in the Cambrian. Well, this is not a debate about facts.
Okay, there's an answer to that, though, and you haven't addressed it. And that is, of course, that one of the issues about the Cambrian fauna is it's the first one that's actually largely skeletonized. And one of the problems we have with the fossil record of soft-bodied organisms, you don't get to see a lot of the details of soft tissues. You get rare examples like the Ediacara fauna or the Xinjiang fauna, the Chinese Cambrian, which allow you to see things that normally aren't fossilized. And during that period of time when they're soft-bodied, we get lots of change we just aren't going to fossilize too well. So there's an event, something going on right there about the earliest Cambrian, skeletonization gradually kicks in. At that point, you're going to start to see things you couldn't see before because the skeleton preserves, and it preserves stuff that was otherwise hard to see in soft-bodied fossils. There's another issue here, which is something that has not been addressed. This is talking on very simplistic terms about neo-Darwinism, as if it's back in the fruit fly generation work of the 40s and 50s. If you guys have paid any attention to what's been done in the last 15 years, everything now is focused on what's called Evo-Devo, evolutionary development. Okay? Let me finish my point here. Don't keep interrupting. Okay? Evolutionary development has proven that there is a lot more to it than just population genetics, and especially a lot more than just fruit flies in cages. What's happening now is people are looking at embryos and looking at how embryos develop, and they're finding that there's all sorts of stuff that goes on at fairly rapid rates and very large scale with relatively small genetic change. That's particularly relevant to the whale example we just heard about. If you read some books by Hans Tevis and the others who are working now with whale embryos and looking at how these work, it turns out that many of these systems that he claims are impossible to evolve on a stepwise basis are all coordinated with each other and are developed products of embryology. And that if you have an evo-devo mechanism where just a few genetic switches kick in, this can happen quite quickly and all in a coordinated fashion. Not that 7 million years is very quick, even by fruit fly standards, okay? We're talking about a fairly long period of time. Most of what Dr. Sternberg presented as an extrapolation falls in the same problems with extrapolations in general. You try to generalize a rate over a long period of time and assume that it's linear, assume that it's constant. That does not work. For example, you cannot talk about whale population sizes. Right now, whale population sizes are at a minimum because of overhunting and overfishing. They may have been much larger prior to humans being active whalers. When you're talking about early whales, they're much smaller in body size. They might have a much larger population. We simply don't know. But they're not constrained by the same things that very large whales are. I mean,
Dr. Prothero, you have to end now, so
Okay,
we can give the other side an opportunity to rebut.
A couple of points I'm going to hand off to my colleague when I'm done. First of all, did you notice the condescension there? You know, if you guys had been following the literature with the recent developments, I think Dr. Sternberg, who is a trained evolutionary biologist with 2 earned PhDs, who's worked at the Smithsonian and the NIH and who publishes in the field, has been following the literature. Secondly, I've been following the literature on the Cambrian as well. There are 15 phyla alone that are known from soft-bodied parts. In the Chengjiang, in the Mao Shashan Formation, that documents the sudden appearance of those new phyla. In a layer just beneath it, a Precambrian layer, there have been preserved small, microscopic, soft-bodied sponge embryos, but none of the ancestral forms to the Cambrian phyla that arise just subsequent to it. Now ask yourself a question. If those sediments can preserve small, soft-bodied embryo, why don't they preserve the hard-bodied ancestors to those phyla that first arise in the Cambrian? This is not a problem of missing fossil evidence. It's not a problem that things aren't being fossilized because the soft-bodied parts can't be fossilized. So, and now Rick had some comments.
I have several comments directed to both of my opponents. Number one is with regard to the quote-unquote fossil fallacy that I used. I accept that transition. I'm not arguing that. Where are the transitional forms? What I'm arguing is that that window of time is very short, and yes, the changes are dramatic. So my question isn't where's the Ambulocetus, or where's the Pakicetus, or where's the Georgicetus? No, my question is where's the mechanism? Now he also mentioned, well, we've got 3 billion years of life. That's what you've got to use as your backdrop. No, you don't. I picked a very easy problem according to the literature. It's a transition that is reasonably well worked out. Yes, you can look at the embryology, and yes, you can follow the features, or you can look at Kempf's work on the reptile to mammal transition, and on and on and on. But the thing is, given a certain window of time and tabulating the number of changes, if you are going to assume a population genetic mechanism, then you can apply certain equations. Now he says, well, of course, this is from the 1930s and 1940s and 1950s. No, I used recent mutation rates. And here's the interesting thing. Speaking about the recent literature, Dr. Prothero, and this is a lot of work that Michael Lynch has done, who is no friend to creationism or intelligent design, I might add, is that when you look at mammalian and vertebrate population sizes, the equations of natural selection don't apply. Genetic drift is a rule. I brought the papers here. In his book, 381 pages, he devotes literally a page, about a sentence, to population genetics. What he does present, Dr. Prothero, I should say, what he does present is a 4-winged dragonfly and an 18-winged dragonfly. And the caption to this is the evolutionary mechanism by which Hox genes allow arthropods to make drastic changes, in their number of segmentation and wings, etc. Now, of course, and then he cites to another figure. Well, the problem is this. We have a plethora of such mutations. You can get a catalog of Drosophila mutants. Right now, they are mutating. There's a project to mutate every single mouse gene, and over 95% of those genes have been mutated. Now, my challenge to both of you is go to those catalogs. You can pull those papers right off of PubMed.org, the NIH's literature. look through those and tell me what number of them are of the type, yeah, they make dramatic body changes, but many of them are negative. I'm not denying that such changes could have happened. I'm not denying the fossil sequence. And I'm not arguing for more transitional forms. But what I'm saying is one thing to show a mythical 18-winged dragonfly next to a 4-winged dragonfly, and to say that, therefore, the evolutionary mechanism has been worked out.
Do you mean there has never been an 18-winged dragonfly that we know of?
I consulted a fossil dragonfly expert, and to my knowledge, there has been no 18-winged dragonfly known.
So how does a picture of one demonstrate the creative power of natural selection?
It's an assertion. But the point is, it's done all the time. Here's a paper, for example, on the reptile to mammal transition by a fellow who, again, is no intelligent design creationist. He just said, here we have a transition. Can this be explained knowing what we know? And no, you must invoke some other type of scenario. In his case, he opts for self-organization theory. I picked a very narrow scope, and this is done all the time. People pick tractable problems.
It's called scientific analysis.
Yeah. It's called developing a testable hypothesis and working on the backdrop. Thank you.
Okay, are you gentlemen through interviewing each other? Like a dog and pony show over there.
I'm happy to interview you too, Mike.
The point of what I was challenging about the question of intelligence and gaps. So Dr. Prothero gave you an answer to the question of where those structures come from, so-called abruptly, although you admitted it. By abruptly, Dr. Sternberg, you meant a few million years. Well, with Evo-Devo, we can see these kinds of dramatic changes happen very rapidly. So that's our answer. That's one of our answers. You don't accept that. Well, what is your answer to it? How many acts of intelligence or creation or whatever word you want to use do you think happened? And more importantly, if you're going to act like a scientist would want to know, how did it happen? What's the actual mechanism of the intelligence, the act of creation? So I'll just pick one of your many on your list. The fluke of the motion of the tail from side to side to up to down. Mm-hmm. Okay, how do you think the intelligence changed that? Do you think the intelligence manipulated the genome? Did he or she use a combination of Evo-Devo, some embryological developmental changes? Or do you think the intelligence spoke it into the language and said, I hereby command you to fluke up and down rather than left and right? What do you think actually happened? We'd like to know.
Well, what I think actually happened is that, yes, you do have a series. And by the way, making jokes is not an adequate scientific response. What I do think is that there are alternative scientific theories that should be investigated. You keep trying to paint me into this corner that I am one of the established intelligent design theorists or that I am a creationist, when I'm on the public record stating what I actually think. I'm a structuralist. And so I do think, yes, there is a scientific explanation. And I do agree with population genetics. What I do not think is that just assuming that you can get a series of DNA changes over time is going to give you these dramatic changes in body plans. I came here to talk about one thing and one thing only, and that is the efficacy of the neo-Darwinian mechanism. I did not come here to talk about intelligent design and creationism and the existence of God, or whether or not with respect to the house mouse, every sperm is sacred. I didn't come here to discuss that. And that is what I'm talking about, just one simple thing. Whether or not, when we look at these transitions, a slice of the fossil record, accepting the sequence, whether or not, by standard population genetic formulations, the explanation that you assume is the correct one. It came out in 1859, was gussied up in the 1930s, and is generally good to go by the consensus. What I'm arguing is that it does not have traction. Natural selection doesn't have traction.
Okay, but we're really close here to finding some agreement. You said you're a structuralist, so do you think that the change of motion from left and right to up and down in the whale happen because of some inherent natural structural change that occurs because it's built into nature? That is, it's part of the natural world? Or do you think an intelligence reaches into our time and space, into nature, and actually manipulates the genome?
Michael, why don't you ask me about that, since I'm the advocate of intelligent design?
I'll ask you, Stephen. What do you think?
Richard is a skeptic of neo-Darwinism. He's also a skeptic of your Evo-Devo models with Hawk's genes. Hawk's genes have big problems. For one thing, they're not good explanations for the origin of new body plans because they're expressed late in the development of organisms after body plans have already been established. They also produce these grotesque morphological disparities like legs coming out of the head of a fly, the Antennapedia mutation. These aren't promising avenues for future evolutionary development. So just saying the words Evo-Devo doesn't solve the problem. If that's part of your evolutionary theory, that's not adequate from our point of view either. I am an advocate of intelligent design. We've debated on that topic before, and we stayed on that topic. I'm happy to come back to do that. I see evidence of intelligent design in the origin of life. I've written a book about that. I don't think it's an argument from ignorance. I think it's an argument from positive evidence, from the evidence of the information and the information processing system that's in living systems. That's an artifact of one and only one type of cause based on our experience, and that causes intelligence. I'm perfectly prepared also to say that the best explanation for the Cambrian explosion, what I call the Cambrian information explosion, also involves intelligence. I don't think it's an inherently disreputable idea to think that an intelligent agent, even a deity, infused information into the history of life at some point. That's only disreputable if you presuppose that there can't be such an entity. If you see evidence of the distinctive activity of intelligence in the history of life, why not talk about it? Why not infer it? So I don't think beginning to think about whether there's other instances of design or other occasions in which design might have been suffused into the environment, I don't think that's an inherently disreputable thing. And your line of questioning suggests that we should at this point fold up because we might have to admit that the design occurred more than once. Well, so what? Why is that disreputable? If there is a designer, that entity could have acted on more than one occasion.
Okay, let me rebut that very quickly here. First, to the point that was argued about the flukes in the whale. We actually have data on that. Okay, the fossil record is actually surprisingly good on that. It turns out because you look at Ambulocetus and many of the early whale fossils, they're like most mammals. They actually move in an up and down motion of their spine when they run. And Ambulocetus has vertebrae which show clearly that it has an up and down motion not only in its spine but all the way back to the end of its tail. There's no possibility, given the canalization that these animals have, that they're ever going to have a side-to-side motion of the tail for swimming. The fluke is already constrained to be that way. And also, in answer to what Dr. Sternberg said, one of the things he doesn't mention about that sequence of fossil whales is that every one of those fossils has a slightly more advanced condition in many features, and they don't all do it all at once. Some of the early features appear as early as the terrestrial pachycetids, which have already got aquatic ear regions and all sorts of other features, and yet they're pretty terrestrial looking in their body skeleton. Others appear in later fossils. It's a stepwise mosaic process. It's not all within 2 or 3 lineages in that particular thing. So it's not like, and if we had the soft tissues, we probably could see more there, but that's where Evo-Devo comes in. It allows us to see how these soft tissues might have come in packages and how they're controlled by very similar mechanisms. So it's not inexplicable, especially if you use modern thinking rather than obsolete ideas about population genetics and extrapolism. The second question, again, is if Dr. Meyer keeps on adding his intelligent design argument there, he's retreated out of science once again. It's supernatural. It's not a testable hypothesis because he will not allow it to be falsified.
It is testable, and it's testable in the same way all historical scientific theories are testable. You ought to know about the method of historical scientific reasoning. I show in the book, Signature in the Cell, that the case for intelligent design is based on the same method of scientific reasoning that was used by Darwin and by Lyell. That method is a method called the method of multiple competing hypotheses, standard in geology, where I was also trained. And it is and the hypothesis of intelligent design is testable by comparing its explanatory power over and against its competing hypotheses, and it's also testable by comparing the predictive success of the theory. The theory, for example, has predicted that the so-called non-coding regions of the genome, which were said to be junk by the Darwinists when it was first discovered, and was affirmed to be junk by Michael Shermer as recently in his 2008 book. Intelligent design advocates have been predicting since the early 90s that the non-coding regions of the genome would be shown to be importantly functional. Those predictions have been confirmed. In fact, overall, the non-coding regions of the genome function
incorrect.
That is correct.
Incorrect.
No,
I have it right in front of me here.
I don't think you want to argue about junk DNA with Richard Sternberg at my side. He's writing a book about it.
I'm happy to.
Yeah.
Okay. I did a whole bunch of
Gentlemen,
research on
we
this.
don't have time for that, I'm afraid. I'm going to have to go
I have
to
the rebuttal if
Anyway,
anyone wants to hear it.
intelligent design has made a prediction about junk DNA not being junk that makes it scientific. We think the evidence has come in overwhelmingly. In fact, it's not we, it's coming in the scientific literature every week that shows that the junk is not junk, it's importantly functional.
Okay, let me answer that one before it gets passed over. It turns out, yes, the early naive Darwinists before this discovery of nucleotide sequencing thought everything was functional, and so they were shocked to discover in the 1960s with the very beginning of DNA sequencing and actually from the very primitive techniques they had like gel chromatography that there was a lot more DNA than seemed to be needed. And the basic thing is that there's a whole series of things in the DNA that clearly cannot be functional, that are junk. We don't know how much is junk, but enough of it is that it's clearly non-functional. I'll bring up one that was thrown at Dr. Meyer in Oklahoma a few weeks ago and apparently didn't know how to answer, and that's endogenous retroviruses. These are retroviruses that insert their DNA back in, or their DNA back into your cells when they infect you or when they infected your distant ancestor. They lock that in, and then your cells carry this, it's sort of like a scar tissue. You carry this dead virus DNA generation after generation after generation, no longer capable of producing those viruses, is evidence that your distant ancestors were once infected and it no longer has a function. And everybody who works on that agrees there's no possible functionality to this. It's completely non-coding. Pseudogenes are also once function genes that have lost their coding. Maybe some portion of what we used to think was non-functional turns out to be functional, but most of it apparently is non-functional and non-coding. You can see that very clearly if you look at things like how much DNA it takes to make an organism. Frogs and salamanders, ferns and salamanders, which are, most of us concede, a little bit simpler than us, have 100 times more DNA than we do. There's even an amoeba, which is called Protopolychaeus debium, which has 200 times the DNA of a human, just to make an amoeba, okay? Clearly not much of that is in use to make something as simple as an amoeba. An onion, one species of onion has 5 times the DNA that humans have, another species has 20 times. These are 2 species in the same genus Allium. Clearly, that can't all be functional DNA if you have that much variation within a genus and that much variation from the simplest amoeba all the way to things like frogs and salamanders. So there's a lot of DNA that's not coded for, and I would say that majority, by far, the people who actually work on this would say that most DNA is still non-coding.
Dr. Prothero, you're a geologist. We have a genomics expert to my right who'd like to comment.
I also had a degree in biology, and I've done a lot of work on this.
Well, yes.
This is a competition between who's got more of a degree. You'll have the final comment, and I'm going to go to questions.
Okay, I want to respond on the retroviral sequences topic. He's absolutely right. There are hundreds of thousands of copies of these virus-like sequences in our chromosomes of mammals and fishes and even the yeast cell. Now, what's interesting is that he's wrong on a number of points. Here's the first point. One of the first class of sequences to be expressed shortly after the first or 2-cell embryo, that is from the zygote, including our zygotes, mouse zygote, to the 2-cell stage embryo, first class of sequences are the endogenous retroviruses. And you know, as determined in 2004, is that if you knock those sequences out, you block their expression, you stop embryogenesis at the 4-cell stage. Actually, it's cited in a paper that Jim Shapiro and I, one of the papers published in 2005, where we dealt with this topic, this whole issue of why this so-called junk DNA is functional. Here's another example. What holds the placenta together is a class of proteins, and they form tethers. And the proteins that are coded are specified by retroviral-like sequences. It's different in the mouse than the ones in the human. If you look now, there are these switches that flip gene sequences on and off. They're called promoters. You can think of them as molecular toggle switches. A recent analysis of the number of these genetic switches in our genome contributed by these endogenous retroviruses. So many of them, they just have to be garbage. 181,000, roughly. So, and you look at the literature, what they're doing now, and this is, the ENCODE project was published in 2007, a series of papers where they looked at not just the sequences, but the expression of sequences, how they're copied into RNA. And what they found, to their surprise, is that most of the expression is taking place in this so-called non-coding DNA. And you can find papers in Nature and Science, genome research, genome biology. Thousands of them are out there now. Go to PubMed.org again, just type in junk DNA and see what you pull up. Don't take my word for it. But what you'll find is that when they investigate these classes of sequences, as numerous as they are, they're finding a whole series of functions. Pseudogenes, for example, so-called pseudogenes, their expression regulates, yes, they don't code for proteins, that's true. Do they look like defunct copies of other genes? Yeah, they do. But you have two papers back-to-back in Nature, and what they demonstrated is that, well, those so-called non-functional RNAs, the transcripts, are regulating other genes. And I'll be happy to provide you with the PDFs and with the references for those papers.
Okay. I have a comprehensive list on page 407 of my book of the functions of non-coding DNA.
I just want to say that we had some wonderful questions up here, and I'm very sorry I can't get to all of them. But I have chosen one for each of the participants tonight, and we'll start with one from Michael Shermer. Can Michael Shermer provide just one example of random mutations erecting whole new genetic information that leads to a new vertical species?
Well, sure. First of all, natural selection is not random. The best definition, I think the T-shirt definition of evolution is from Dawkins, non-random. It's random mutation, non-random cumulative selection. It's the cumulative selection part that drives evolutionary change. One example amongst many, the origins of complex eukaryotic cells. This is the research of Lynn Margulis and her lab, in which they've demonstrated that things like the kinds of cells that you and I are made out of, eukaryotic cells, in fact have within them organelles that were once prokaryotic cells, simpler, self-sustaining organisms that then combined into this sort of non-zero cooperative process that gained a selective advantage and became more complex. Dr. Margulis has shown over and over again that these simpler organisms acquire entire new genomes. Just like that, they double their information content and double it again and double it again. And you can watch it right there in the lab. And you can see it in our genetic fossils. You can see it in the mitochondria of your own eukaryotic cells has within it DNA. Well, we already have a complement of DNA in the nucleus of our eukaryotic cells. Why would there be another set of DNA in our mitochondria? The answer is because those mitochondria used to be simpler prokaryotic cells. So that's just one example among many. Thank you.
Okay. To the ID side. If mutation and selection is not sufficient and there is no external influence, then what mechanism active is responsible for new evolutionary forms?
The question of mechanism is a subset of the question of cause. And where we invoke an intelligent cause, we invoke that in place of a materialistic mechanism. A mechanism is just a material cause. So what ID does is it infers the activity of a designing intelligence from the presence of effects which are known to arise from one and only one type of cause, and that is intelligence. So ID does not provide a mechanism, but it does provide a cause, and that cause is intelligence.
Thank you. Dr. Prothero. Prothero, sorry. You stated that labs are close to creating life from non-life. Without the information blueprints, the inherent genetic information already present, explain how it's possible to create life devoid of pre-existing information?
There are actually several labs on this, and you can Google this and read it up on your own if you want. A recent paper in New Scientist talked about one of these labs in Britain. The Venter lab, the same guy who privately sequenced the genome of the human, is also doing something similar to this. And basically they're doing a very reduced system where they're doing the minimal amount of genetic code needed to make something reproducing, copying itself faithfully. And they've got quite a sophisticated setup which is working out at the moment quite well. They haven't gotten to the point where it reproduces completely in a full living sense, but they're already at the point where they have a lot of the pieces of the puzzle fit together. So it's happening. It's just we don't have the time and the diagram to show you all the biochemistry for it.
I address that in my book. That's called The Intelligent Engineering of New Genetic Information.
The intelligent design side is the fossil hominid evidence along with human chimpanzee genetic commonality, sufficient enough evidence for you to accept a neo-Darwinian explanation of human origins?
I'll respond to that. What I would say is this. And I'll speak for myself, I accept the hominid sequence. I do not accept a neo-Darwinian explanation for it, mainly because given, again, the breeding population size and given the repeated bottlenecks that the population, the lineage supposedly went through, and again, I accept that, what you're left with as a causal mechanism is not natural selection but genetic drift. This has been repeatedly shown. Ira Walker has done work on this. Michael Lynch has written extensively about this. So when you look at the sequence, pick an ancestor, Australopithecines or Artie, what have you, and you want to walk through until you get to Homo sapiens. If you accept that sequence, what you're left with as a causal mechanism is essentially what's called a neutral or near neutral process, or what's essentially a random process. So I think and again, this goes to the testable hypothesis, the opposition seems to think that if you present a theory and you have an examination of that theory and you say, well, this aspect of the theory is found wanting, then you automatically lapsed into some supernaturalism. Well, that's not the argument I'm making at all. I'm saying that if you accept the sequence, the neo-Darwinian mechanism, to my lights, does not appear to be sufficient because you have to invoke something like genetic drift.
Rick, isn't it also the case that the non-coding regions of the genome in humans and chimps are species-specific? So that old argument about 99% of human and chimp DNA is identical isn't that the 99% of the 2 or 3% that's coding, isn't it?
Well, first of all, roughly about 1%, 1.5% of the mammalian genome codes for proteins. That aside, a lot of the alignments that are done, what many people do not take into account is that aside from the fact that the chimpanzee genome, the sequence that is, has not been completed, some regions haven't been sequenced, is that in order to get the alignments that you see, to get the so-called 98% similarity, you have to rearrange the sequences. You have to count for insertions and deletions and rearrangements and things like this in order to get it to add up. And then you also have to factor in that you have a number of species-specific sequences, like retroviral type sequences, and like so-called jumping genes, which reduces that further. And the fact of the matter, and there's a paper that came out in Science, it's called The Myth of 1%, is that we really don't know. And I haven't seen any paper that has come up with a definitive figure. We don't know the actual percentage. That is the actual percentage of similarity between the humans and the chimpanzee. Anyway, and I can find the reference for you. But it's an insightful paper. Some gymnastics has to be done at the sequence level to get them to map on. Now, of course, Dr. Prothero, Dr. Shermer will respond and say, well, yes, of course, and the reason that you have to perform these alignments is because, well, of course, a lot of evolution has occurred. Well, perhaps. But nevertheless, you cannot say we've got such close similarity by taking a few sequences, lining them up, and then adjusting them to make it look like you've got a lot of similarity. The fact is our chromosome complement to some extent is different, but also if you look at the raw sequence, do the raw sequence comparisons, you will find that there are some significant differences between the two species in terms of the genetic complement.
Gentlemen, I have to ask you not to ask each other questions. That privilege actually belongs to the audience right now. You got away with it this time, but you won't again. To Dr. Shermer, do you believe that reason is an emergent property of molecules, and if so, why should we trust anything you say?
Well, first of all, you shouldn't. The first principle of skepticism is be skeptical of the skeptics. So obviously, but I think there's something deeper actually in the question on to what extent should we trust any kind of inductive process practiced by science or reason or logic or something like that. Well, as opposed to what? As I started off saying, there's only two explanations. There's the scientific one based on reason and logic and evidence, and then there's everything else. And the one that works the best, just pragmatically, is science. You want to get a spacecraft to Mars, you use astronomy, not astrology. Just because it works is the best answer to that question.
Here's a question for all four panelists, participants tonight. And I'll address it first to the negative side. Does the absence of a new theory necessarily mean that the present theory is sufficiently adequate?
Try us again on that.
Does the absence of a new theory necessarily mean that the present theory is sufficiently adequate?
No. No, I would say definitely not. I mean, there have been a whole, the history of science is replete with examples of theories that at once seemed very reasonable and appeared to fit the data, that were, in some cases, well worked out mathematically even, mathematics at the time. And later, as more and more, as data were accumulated, it became clear that there were problems. And you could add epicycles and make modifications to the theory, but eventually it gets to the point where you say, well, this theory simply doesn't work. It may be true in some cases, but as an all-embracing, all-encompassing theory, it doesn't hold. And then there's a period of time where alternative hypotheses are posed. There are parts of the old theory are salvaged, but to question an existing theory in the absence of a competitor theory does not mean that that default position has to be accepted. In fact, I would say that accepting any theory as a foregone conclusion it's profoundly unscientific.
Let me answer on the other side here. That's, in fact, one of the strengths of science, okay? We're humans. We are trying to investigate the world by the best techniques we have. We're applying the rules of natural law and science as best we can. We're always revising theories, which is never a final solution. We're not at the point where we know all about the world and probably never will be. That's fine. Scientists are used to uncertainty. The point being, this is the way science operates. And then when a better theory comes along, we're willing to revise and sometimes throw out old theories. What we don't do is fall back on supernaturalism. We're not allowed to do that as scientists. That is a non-explanation. It doesn't fit.
Well, that leads me into my final question, and that is to both of you, both sides. Can intelligent design incorporate evolution? Can evolutionary theory incorporate intelligent design or aspects of it? Why don't you go first?
Oh, sure. Well, I guess in a way that I think Francis Collins does in his book, The Language of God, in which he presents the argument that the science stands or falls on its own regardless of what your religious beliefs are. But it seems reasonable to argue that a deity or an intelligence or something like that built into the system itself from the very beginning processes that lead to complexity and design, features, morality, wings, eyes, whatever. That's not my position, but it seems like that's a reasonable one that Francis Collins argues. But that requires no intervention in the space-time continuum since the origins of the universe. It's just built that way. And so whether there's a deity outside of that or not is sort of irrelevant. It's sort of, you have to kind of take a leap of faith. Beyond that, as soon as you start allowing an entity, an intelligence of some kind to enter into our space and time, we want to know how does he do it? How does he operate? Does does the intelligence use the laws of nature as we understand them to create things, or does he use some other force that we don't know about? And so it's a little unhelpful to say words like intelligence or intervened or created. That these are information. These are just words that don't help us actually get to the core of the explanation. How does it happen? What's the actual molecular structure, the electromagnetic force, the whatever? That's really what we need to test.
I'm going to follow on that with another question, and that's, is it possible that the complexity of life, the deep complexity of life, is beyond human understanding?
Me?
Yes.
Oh, well, I like to think it's not beyond human understanding, or else we'd give up, right? So, and we got to go to work tomorrow and do science. So, well, I mean, there might be something if you push it back far enough, like where did the stuff that banged in the Big Bang come from, or what was there before the multiverses, or I mean, you could find some infinite regress, and maybe there's things like solving the free will and determinism problem that probably are best resolved over adult beverages late at night because we're restricted by certain language restrictions that we use in our cognition that make it probably impossible. But that's more of a Wittgenstein kind of philosophical linguistic problem than it is a scientific one.
Gentlemen.
Can intelligent design incorporate evolution?
Yes.
That's the question. Absolutely, depending on what is meant by the term evolution. And that's one of the things we've been trying to insist upon tonight. There's the observation of change over time. That's one meaning of evolution. There's the idea of universal common ancestry. That's another meaning of evolution, which implies continuous unfolding and continuous change. Clearly, an intelligence can cause change over time. Intelligence can cause continuous change over time. But the third meaning of evolution, the specifically Darwinian or neo-Darwinian meaning, is the idea of a purely unguided process, in particular natural selection acting on random mutations of various kinds. If that's what you mean by evolution, if you're referring to the theory of evolution, which is with its affirmation of a purely unguided, undirected causal mechanism for the origin of the appearance of design, well then clearly intelligent design parts ways with that meaning of evolution. There are many theistic evolutionists who will say, yeah, I think that God is directing the evolutionary process. That's fine if you mean by that evolution number one and evolution number two, but even God can't direct an undirected process. That becomes not a theological problem, but just a logical one. And so I think this brings us back really to the central point of the debate, which is whether or not there is compelling evidence for the creative power of that unguided neo-Darwinian process. And Dr. Sternberg and I have argued tonight that there is not.
Okay, we're going to go to concluding statements now, and I'm going to ask the positive to lead on that. 5 minutes.
Okay, I'll say a few things and let Michael wind up. When I accepted the terms of this debate, I was given the understanding that it would be an origin of life. And as we've said several times now, nothing that they've said over there is relevant to it. I showed you a whole series of chemical stories and reactions and chemical laboratory work, which has shown that in almost every step, from the simplest amino acid right up to complicated cells, which Michael mentioned, eukaryotic cells and the symbiotic mechanism of Margulis, almost all those steps now have been done in the laboratory. We don't have all the answers yet, but we have much or most of the story needed to figure out how life originated. And the point behind all this is that that is what's central to what's being talked about tonight. They haven't addressed any of it, which is surprising given that that was the title we were given. And the point being here is that all these work in this science was done in laboratories by people who work on this problem directly, don't tour around the country writing books on biochemistry and they're not trained in biochemistry. And in particular, what they're doing is real science. They don't fall back on supernaturalism just because they haven't solved the problem. The problem is about solving things that can be solved. We don't have all the answers yet, but we're making much more progress than they'll give us credit for.
Okay. All right, hang on. Okay. Well, all right. Let me just read a short statement from Stephen's book. By the way, Stephen, I don't think you just fell off the turnip truck. You're a pretty smart guy.
Thank you, Michael. So are you.
Now that we've made up. So he writes here, the activity of a theistic God could provide an adequate explanation of the evidence of intelligent design in biology, though other entities could conceivably do so as well. So what would those entities be? I think it's an interesting question. Let's say it turns out that the origins of life did not happen here on Earth. Maybe it happened on some other planet, and a piece of the planet got knocked out into space by a meteor impact and ended up here. Or in a more sci-fi scenario, let's say we found out that the Vegans sent it here on a pod, and we found the blueprints out in Blythe, buried in the desert, and there it is. We now know how the origins of life were formed by these other intelligences. Okay, well that would be pretty interesting, and NASA would get some new funding from Congress, and it would be a great discovery, but it wouldn't answer the question of the origins of life, would it? I mean, we still want to know something beyond the Vegans did it. Well, where did those guys come from? Oh, well, they were created by some intelligences in Andromeda. Well, okay, that's interesting also, but where did those guys come from? So at some point, we want some natural explanation, not just an intelligence, because we can always ask the one more regressive question, well, who created that intelligence? And so by the arguments of the intelligent design theorists, it seems inevitable that we're going to want to know what, by your own arguments of inferring design, then it seems reasonable to ask, well, then who designed the designer? And I don't think it's a sophomoric question, well, who made God? Yeah, that's what high school kids ask. Well, what's wrong with that? I mean, it's an interesting question. And the inference from design, I think part of the problem is that it's really obvious something like the difference between the face on Mars, which is obviously just an eroded mountain, but our facial recognition software kicks in and we see a face, versus a Mount Rushmore face, which we clearly recognize has intelligence behind it. The reason we're able to infer that is because we have vast experiences of ourselves as intelligent beings making things, artifacts. We have no experience at all of a super intelligent designer coming down and there right before us in the workshop makes some DNA for us or creates an eye for us. That's just pure inference, and there's no known logarithmic process, some algorithm we can apply and say, yes, that is an intelligently designed thing, that DNA, but the RNA isn't. See, there is no testable thing yet. So, I mean, if you guys come up with that, okay, that would be interesting. Finally, I think ultimately the best you're going to be able to find ever in your process is some natural process, some natural forces at work. So let me just make an analogy, my last minute and a half. In a different field that I deal a lot with, and that is ESP and psychic power and so on. And there's a fairly rigorous scientific theory about how this may happen, that people can read each other's minds. It has to do with quantum physics, and that the collapse of the wave function inside these atoms, inside our neurons, happens in a particular pattern that goes across space into your skull and causes your neurons to fire in the same pattern, and that's how we can read each other's thoughts. Okay, I don't happen to think this is true, but it's proffered by Roger Penrose, who's a legitimate scientist and so on. Anyway, it's an interesting theory. But if it turned out to be true, that would not be the paranormal. That wouldn't be ESP. That would just be psychophysics or neuroquantum physics or something like that. It would just be incorporated into science. And so, gentlemen, I think the best you're going to be able to find with a designer or some kind of intelligence is just yet some other part of nature that we have yet to discover, and then it just gets incorporated and we're just doing science again. And I think that's the best your program can give us. Thank you.
Dr. Meyer and Dr. Sternberg. Concluding statement, 5 minutes.
I think both the gentlemen opposite are insufficiently sensitive to the importance of mind in the cosmos. Our minds. We do lots of cool stuff. We know what a mind can do. We know what it means to be intelligent. As long as we are now debating intelligent design, let me respond to the points that were made. We didn't think this was a debate about we thought it was about the origins of life and evolutionary theory sufficiency, which meant it was mainly about the mechanism, the cause offered by evolutionary theory, which is natural selection and random mutation. But if we want to talk about the origin of life, I'm really happy to do that. I did just write a long book on the topic. Dr. Prothero mentioned in his opening statement, he talked about Stanley Miller and his synthesis of amino acids. Miller and many other prebiotic chemists repudiated the relevance of those experiments late in life because they realized that the conditions under which the amino acids were synthesized did not simulate the conditions on the early Earth. That was problem one. Problem two, when the amino acids were allowed to collect and sit around for a while, a sludge, a chemical sludge accumulated called melanoidin. In order to keep that reaction from taking place between desirable amino acid and byproducts, problem known as interfering cross reactions, intelligent investigators have to intervene and take out reaction products that would cause biochemical reactions to go in an unfavorable direction. That's the hidden hand of intelligence, in this case the scientific investigator, playing a role in moving life or chemicals in a life-friendlier direction. But notice what's happening. The scientific investigator thinks that this is all natural, but what's really going on is a mind is directing the process. Dr. Prothero also talked about these these experiments with RNA, where the investigator is literally sequencing the RNA gene. That's, again, intelligence creating information. What goes on here is that with the materialistic mindset that has grown up around science, that scientists they're looking at nature, but they're not noticing their own intervention in what intelligent minds do. And when you step back and notice that minds have certain powers that material entities do not, you can begin to make inferences about the activity of mind in the past. Now, Dr. Shermer raised the whole question of who designed the designer. One of the chapters in my book that I'm happiest about is the chapter 17 in which I take that on. I'll give you a brief synopsis of my response to that. I agree with him that one of the problems with invoking an immanent intelligence, an alien within the cosmos, is that it does lead to this kind of infinite regress. That's one of the reasons I favor the theistic design hypothesis over the spaceman hypothesis favored by, for example, Richard Dawkins, or at least tendered by him at the end of the movie Expelled, or tendered by Francis Crick. Another reason I favor the theistic design hypothesis is that there's also evidence of design from the very beginning of the universe and the fine-tuning of the laws of physics and chemistry, something I agree with Francis Collins about. When people say, well, who designed the designer, they're just, again, privileging materialistic thinking, materialistic explanations. You can say the same thing of the evolutionary hypothesis. So you accept the neo-Darwinian hypothesis, you can ask who evolved the evolver. If you concede, as many evolutionary biologists have done, such as Richard Dawkins, that there is no adequate undirected evolutionary explanation for the origin of the first life, you do the same who designed or who evolved the evolver infinite regress question on him. He accepts biological evolution, but it can't get started without chemical evolution, and he accepts that there isn't such a process. The real point is that in any metaphysical system, and now I'm not talking about scientific reasoning, but in any ultimate metaphysical explanation has to go back to some primitive, something from which everything else comes. And the question in modern philosophy of science is what is the best candidate to be that primitive, to be that thing from which everything else comes. I think post-Big Bang theory, post the solutions to the field equations of general relativity, implying that you have a true singularity at the very beginning of the universe, in which the spatial volume of the universe curves on itself so tightly that you have a true singularity. I think the best candidate is to be that thing from which everything else comes is not a material entity. How much space can you put in zero spatial volume? None. I mean, how much matter can you put in zero spatial volume? So I think with the new cosmology, you can ask the question, which of these two metaphysical systems provides a better starting point? I think that's one of the reasons I'm a theist, but we weren't debating that tonight. We were just debating the adequacy of the neo-Darwinian mechanism, that is to say, modern evolutionary theory.
Please join me in thanking all four participants in tonight's wonderful debate.